Does anyone remember where I left on the last class?
Completed charge of proton and electron.
Okay. Uh, Up to this topic, right?
Ma'am, just let me check it.
Okay, please check.
Ma'am, electric charge.
Electric charge.
Yes.
This one?
Yes, ma'am.
No. This is the first topic, na?
Oh,
I think from up to this charges of proton and electron. Last class the network was bad, na? That's why I was unable to take the class. Okay.
Coulomb's law.
Coulomb's law.
Yes, ma'am.
Did I started Coulomb's law?
Just started, ma'am. Not
Okay.
finished.
Okay.
yes, ma'am. Complete.
Okay, so we know that positive and negative charges attract each other and charges with same sign repel each other. So when they attract and repel each other, they use some force to attract that another charge or repel that charge. They use some force on each other. That force is Coulomb's explained this force, and that's why this law is called Coulomb's law. So, according to this law, the magnitude of the electric force between two static point charges in vacuum is directly proportional to the product of the magnitude of two charges and inversely proportional to the square of the distance between them and acts along the line joining two charges. The magnitude of Coulomb's law is given by F equal to kq1 q2 by r square. So the force between two charges, that force can be attraction or repulsion, is directly proportional to the product of the magnitude of the two charges. That means force is directly depends on the magnitude. If the two charges have higher magnitude, the force between them will be higher. If they have lower magnitude, the force will be lower. So F proportional to Q1 into Q2. The force is directly proportional to the product of the two charges, and the force is inversely proportional to the square of the distance between them. Inversely proportional means when the distance between the two charges is low, then the force will be higher. If the distance between the two charges is really long, then in that case the force will be low. So force always inversely depends on the distance. As distance increases, force decreases. As distance decreases, force increases. So square force between the two charges is inversely proportional to the square of the distance between them. Square of the distance between them, as the distance increases, the force between them decreases. Force between them will be really low as the distance increases. So we know that F proportional to Q1, Q2 and F proportional to 1 divided by R square. Inversely proportional, that's why 1 divided by R square. So combining these two equations, F proportional to Q1, Q2 divided by R square. So to remove that proportionality sign, we will use a constant. That constant is k. So F equal to k q1 q2 by r square. K is the proportionality constant. The force between two charges is called the electrostatic force. So Coulomb's law explains the electrostatic force between two charges or multiple charges. Coulomb's law explain the electrostatic force between the charges. So where F is the electrostatic force between two charges Q1 and Q2 separated by the distance R. The distance between the two charges is R. That's why F proportional to 1 by R square. K is the proportionality constant and the value for K is 9 into 10 to the power 9 Newton meter square divided by Coulomb square. So this is the value for K. If someone asks you what is the electrostatic force between two charges and you have given the magnitude of the charges, then you have to put the value of K here, 9 into 10 to the power 9 Newton meter square divided by Coulomb square. You have to put the magnitudes of the two charges and you have to put the value of the distance, and putting all these values in this equation we can calculate the electrostatic force between two charges. Electrostatic force have two kinds of electrostatic force are there. One is attraction and the other is repulsion. One more thing, it says that the force between the x along the line joining the two charges, that means the force always goes in the straight line joining the two charges. The direction of this force will depends on the sign of the charges. If attraction, the charges are positive or negative, that will depend according to that, that this direction of the force will be calculated. That direction will depend on the uh, sign of the charges, whether the charge is positive or negative. Next topic is electric field. A positive charge or a negative charge is said to be create its field around itself. The space around a surge in which another surge particle experiences a force is said to have electric field in it. The electric field is a vector quantity. The direction of the field lines depend on the sign of the source charge. Electric field vectors point away from positively charged source towards the negatively charged source. So, the area around the charged particle up to which it can attract or repel another charged particle is the electric field of this charged particle. So to check the electric field, we will take two charges. One charges will be taken as the source charge and one charge will be the test charge. With the help of the test charge, we will calculate the electric field of the source charge. So the source charge can be a positive charge as well as a negative charge, but the test charge is always taken as a unit positive charge. So when we bring the unit positive charge around a source particle, since if the source charge is a positive charge, it will repel the unit positive charge, right? So we can see the up to which it can repel that charge, unit positive charge. If it is not repelling that charge, that means this is not the electric field of that source charge. Only up to its electric field it can repel that. So in case of a negative source charge, it will attract the positive charge, unit positive charge. We have to see whether it is attracting that charge particle or not. If that negative source charge is attracting the positive charge, that means we are putting that unit positive charge into the electric field area. If it is not attracting that charge, that means it is beyond its electric field. That's why it is not attracting the unit positive charge. So unit positive charge. So the area around a charged particle up to which it can attract or repel another charged particle is called the electric field of that charge. So electric field is a vector quantity. It has a direction. The direction will depend on the source charge. See, we are taking the test charge always as a positive charge. If the source charge is positive, then it will get repelled. That means the direction will be outwards. If the source charge is negative, it will get attracted, so the direction will be inwards. So electric field is always a vector quantity, and its direction depends on the source charge, the sign of the source charge. So any question? Do you have any doubt on Coulomb's law and electric field? All of you have understood these topics?
Yes, ma'am.
Okay. Next topic, electric field intensity. So, electric field intensity at any point is electric field intensity is determined by the symbol E. The electric field intensity at any point is defined as the force experienced by a unit positive charge placed at that point. So we know that the source charge is taken as can be positive or negative, and the test charge is always taken a positive charge, unit positive charge. Okay, that the test charge is a unit positive charge. When we bring the test charge closer to the source charge, it will get attracted, it can get repelled. So when it get attracted or repelled, the intensity of attraction or repulsion is not same at all points of the electric field. Where as we get closer to that source charge, the intensity of attraction or repulsion get higher. As we go away from the source charge, the intensity of attraction or repulsion gets lower. So electric field intensity is the force experienced by a unit positive charge placed at that point. In any particular point, what is the force of the what is the amount of the attraction and repulsion force is the electric field intensity of that source charge. So since electric field intensity is the force experienced by the unit positive charge at any particular point, therefore electric field intensity E equal to F divided by Q. Okay, or F equal to KQ by R square. Okay, 1 second. Okay, see. So let me show you here. When we put the value of F, what was the value of F from Coulomb's law? K Q, since it is a unit positive charge Q, and if we taken the source charge as capital Q and the unit positive charge as small q, then Q by R square divided by R square. This is R square. This is the value of A. This is the value of F according to Coulomb's law. Since there is a two charges here, one is unit positive charge and the other is a source charge, we taken the magnitude of the unit positive charge as small q and we have taken the magnitude of the source charge as capital Q. So this is the value of F. Q divided by R square, and there is a Q according to the definition of electric field. There is a small q according to the definition of electric field intensity. So this small q and this small q will be cancelled out and the final answer will be for electric field equal to kq divided by R square. So electric field intensity can be defined by two formulas. One is F divided by Q. Here Q is the unit positive charge and equal to KQ divided by R square. Here Q is the source charge, which is here the capital Q is the source charge and small q is the test charge. So E equal to electric field intensity equal to F divided by Q or equal to KQ divided by R square. We have already know the value of K, which is 9 into 10 to the power 9 Newton meter square divided by Coulomb square. And the value Q is the charge of the single point charge of electric point charge is Q is the charge of single point source of electric field. So Q is the charge of the source charge, magnitude of the source charge, and R is the distance from the source charge of the unit positive charge. The distance of the source charge from the unit positive charge is R. So this is the electric field intensity. So electric field intensity is basically the force experienced by a unit positive charge at a particular point of an electric field. Okay, did you understood this topic? Did you understand this topic?
Yes, ma'am.
Okay. Tell me one thing. When I asked to give your attendance in the WhatsApp group, lots of students have given their attendances, but in the class, only 19 students are present. Why is that?
No idea, ma'am.
I have said already that attendance is really important, right? You will be not allowed to give your final attendance if your attendance is lower than 75%. You should know the importance of attendance. If out of 80 students, only 19 students are present, that means you are not interested in the class, you are not interested to learn anything. And some of you just joined the meeting, give your attendance and left the meeting. CR, present. Are you present in the class, CR?
Yes, ma'am. Yes.
Please, from next class, please tell everyone to join the class. Okay. I have completed whole syllabus already. Only one chapter is left.
Ma'am, hello.
Yes.
Ma'am, I was present every class, every single class, but the roll number is not given
Where?
in the student portal.
Your roll number is
I was present. Means two of the video means I can't read the previous one.
from my class.
Yeah, yeah,
Your roll number is 19, right?
yeah, ma'am.
I don't know. I have given the all the attendance in the given in the chat box. I have updated all the attendance given in the chat box. Did you give your attendance in the chat box?
Yes, ma'am. Yes.
I don't know that. I have given all updated all the attendance given in the chat box. Okay. I'll check again. Do you remember in which classes? Do you remember the date? Do you remember the dates of those classes? Zit. You remember the dates or not? No reply.
Ma'am, the previous one. Before.
Last class. Okay, I'll check again. What happens sometimes I update the attendance after 1 day. So you have to check again in between 48 hours. You can give your attendance up to 48 hours now for one class. So you have to check, you should check again because sometimes uh, I get busy and I update the attendances after 1 day. So maybe you check earlier before I updated the attendance.
17 and 24.
What?
17 and 24.
17 and 24. Oh. Okay, I'll check. Uh, Remind me later, okay?
Yeah, sure, ma'am.
Okay, do you have any doubts on today's class? Any doubt on today's class? NCR, it is your duty to check everyone join the class or not, okay? I want more than 50 students from next class.
Hello, ma'am.
Yes,
Ma'am, Coulomb's law to ever কৈ দিবচোন।
Coulomb's law. Okay. Okay, so Coulomb's law means we know that positive and negative charges attract each other, and charges with same sign repel each other. So when the charges attract and repel, they use some force to for the attraction and repulsion process. Okay, that force is called electrostatic force between the two charges. Electrostatic force can be attraction or repulsion. The equation of that force or the formula for that force was explained by Coulomb. So that's why this law is called Coulomb's law. Coulomb's law explained the explained about electrostatic force. So when the electrostatic force, when two charges attract and repel each other, the force is always proportional to the product of the magnitude of the two charges. Only the magnitude, not the sign. Okay, you have to only put the magnitude here. So that means they are directly proportional to the magnitude of the two charges. That means if the two charges have higher magnitude, then the force will be higher. If they have lower magnitude, the force will be lower. That means with the increase of the magnitude of the charges, force also increases. So F directly proportional to Q1 into Q2. Q1 and Q2 are the magnitude of the two charges, and the force is inversely proportional to the square of the distance between them. That means with the increase of distance, force decreases, and with the decrease of distance, force increases. So F proportional to 1 divided by R square, inversely proportional to the square of the distance between them. So F proportional to 1 divided by R square. So combining these two equations, F proportional to Q1, Q2 divided by R square. To get a particular value, we have to remove that proportionality sign. Okay, so F equal to, we put a constant, that constant is K. F equal to K Q1 Q2 by R square. The value for K is the proportionality constant. The value for K is 9 into 10 to the power 9 Newton meter square divided by Coulomb square. So from that equation, we will know the force between two charges. That force can be attraction, that force can be repulsion according to on the basis of the sign of the charges, and they will act on the straight line joining the two charges. Okay. Anyone else have any question? Okay, if you have understood this class, then give your attendance. Okay, thank you everyone.